Hello! In this video, check this out. Let A and B be objects. Then there exists a set, which we call a pair set of A and B, which satisfies the following statement. For all objects Z, Z is an element of our pair set if and only if either Z is equal to A or Z is equal to B. Okay, now this definition only says that there exists a set which satisfies this statement. How do we know that this set is the only set which satisfies this statement? That's what we're going to prove. We're going to prove that given any two objects, A and B, the pair set of A and B is unique, right? It's the only set which satisfies this statement. So now let's get into the proof. Notice we're trying to prove a statement about any two objects. So give me any two objects. I'll call them A and B. Well, from our definition, we know that there exists a pair set of A and B. But our goal is to prove that this pair set is the only pair set of A and B. And to prove uniqueness, what we can do is we can suppose that A and B have two pair sets. I'll call them X and Y. And the whole goal to prove uniqueness is to prove that X is equal to Y. Now, since X is a pair set of A and B, what that means is, for all objects Z, Z is an element of X, if and only if either Z is equal to A or Z is equal to B. And also, since Y is a pair set of A and B, what that means is, for all objects Z, Z is an element of Y, if and only if either Z is equal to A or Z is equal to B. Okay, now our goal is to prove that X and Y are equal to each other. And to prove that, what we can do is we can prove for all objects Z, Z is an element of X, if and only if Z is an element of Y. So, since we're trying to prove a statement about all objects, give me an arbitrary object. I'll call it Z. And our goal is to prove that Z is an element of X, if and only if Z is an element of Y. And we're going to do that by establishing a chain of if and only ifs. And to see how that comes together, check this out. Now, we know that this statement right here works for every object. So it must work for our object Z. So Z is an element of X, if and only if either Z is equal to A or Z is equal to B. Also, since this statement works for every object, it must work for our object Z. So Z is an element of Y, if and only if either Z is equal to A or Z is equal to B. So what we see here is we have a chain of if and only ifs, showing that Z is an element of X, if and only if Z is an element of Y. Putting this together, since Z was an arbitrary object, this means for all objects Z, Z is an element of X, if and only if Z is an element of Y. Right, and that's what it means for these two sets to be equal. And that proves the uniqueness of our pair set. So putting this together, we started out by giving ourselves two objects, A and B. And from there, well, we know from our definition that there is a pair set of A and B. How do we know that this pair set is the only pair set of A and B? Well, we suppose that X and Y are any two pair sets of A and B. From there, we prove that they have to be equal. And so that proves that this pair set is unique. And so yeah, this completes the proof. So that's pretty much it for this video.